Hi guys, welcome to my channel. The Andromeda Galaxy is a barred spiral galaxy about 2.48 million light-years away from Earth. Located in the constellation Andromeda. It is officially designated Messier 31, M31, or NGC 224, and records of its observation in the night sky date back to many centuries. The American astronomer Edwin Hubble was the first person to have conclusively demonstrated that Andromeda was a separate galaxy apart from our own in 1925, and not a nebula as previously believed. Andromeda Galaxy or Andromeda Nebula. Andromeda is our largest and nearest galactic neighbor, and for centuries, it was believed to be a nebula of little significance. French astronomer Charles Messier catalogued the Andromeda Nebula in 1774 as Messier 31, M31, the 31st item in his catalogue of objects to avoid when comet hunting. Originally, Messier wasn't particularly interested in the objects he was cataloguing in themselves. As an avid comet hunter, Messier compiled his catalogue of objects that could be easily mistaken for comets. To help prevent false positive comet identifications, the Andromeda Nebula factored into the great debate between astronomers Eber D. Curtis and Harlow Shapley in 1920 about the scale of the universe. M31 is the largest galaxy in the local group. If it were possible to travel anywhere in the galaxy, the next step would be to visit our 54 or so neighboring minor galaxies, most of them dwarfs, that surround the Milky Way galaxy within a distance of 1.4 million light-years. The next step on our epic journey would involve traveling to our nearest major galaxy, Andromeda. How far away is the Andromeda Galaxy? M31 is located 2.54 million light-years from Earth, which makes it the most distant naked-eye object you can see in the night sky. Finally, we might venture on to the Triangulum Galaxy, M33, located around 3 million light-years from Earth. In the northern hemisphere, M31 can be seen the whole year round, although it is generally best seen from August to February. In the southern hemisphere, ideal M31 viewing is from October to December, where it can be seen low on the northern horizon. Find M31 using Cassiopeia or Pegasus. The constellations of Pegasus and Cassiopeia will be familiar to many people, because they are big, obvious shapes. Fortunately for stargazers, they can also be used to locate Andromeda. Pegasus, which includes the Great Square of Pegasus asterism, is huge, and clearly marked by 4 bright second-magnitude stars. Drawing a line from one corner to the other gives a good idea of where to look for the Andromeda Galaxy. Cassiopeia, on the other hand, is the large letter W formed by 5 stars, and it rotates around the star Polaris depending on the season. If you follow the deeper V, 2 times its depth, you come straight to the Andromeda Galaxy. Why was a galaxy named after Andromeda? The Andromeda Galaxy is named after the area of the sky in which it appears, namely the constellation of Andromeda. This northern hemisphere constellation can be seen from between +90 degrees and -40 degrees of latitude, with its brightest star being the hot blue subgiant called Alpheratz, which is located 97 light-years away and shines with a magnitude of +2.06. In Greek mythology, Andromeda was a princess whose parents, King Cepheus and Queen Cassiopeia, chained her to a rock as a sacrifice to appease the sea god Poseidon, who took exception to Cassiopeia's boast that her daughter was more beautiful than the sea nymphs, Nereids, who often accompanied him. Their sacrifice was intended to stop Poseidon from destroying the city of Ethiopia where they reigned. But Andromeda was saved at the last moment by the hero Perseus, riding on the winged horse Pegasus. The name Andromeda derives from the Greek for ruler of men. M31 appears 6 times the size of our Moon. The Andromeda Galaxy is best observed when it's reasonably dark outside, because then it is very easy to spot. However, it may come as a surprise to most people that the Andromeda Galaxy appears 6 times wider than the full moon in the night sky. Even the naked eye portion, which appears as a cloud of faint light, is about the size of the moon, 0.5 degrees of sky, while 10 times 50 binoculars will reveal a much larger image. Using an 8-inch, 200mm telescope, M31 presents a spectacular sight with its diffuse dust lanes stretching out from its bright center. And if these vast spiral arms are included, the Andromeda Galaxy would cover around 20 degrees of sky, or 40 full moons. Andromeda Galaxy contains 1 trillion stars. There are around 1 trillion suns in the Andromeda Galaxy, compared to between 100 and 400 billion stars in our own Milky Way galaxy. Despite the physical size of M31 being over 2.5 times that of the Milky Way, and containing several times the number of its stars, the mass of the Andromeda Galaxy is only 400 billion times that of our own Sun. The Milky Way is imagined to be considerably heavier, because it probably possesses more dark matter and dark energy than M31. M31 is teeming with black holes. As with all large galaxies, including our own Milky Way, the Andromeda Galaxy has a supermassive black hole at its center. In this case with a mass of 100 million suns. M31 also has a large central bulge much bigger than the one at the core of our own galaxy, which allows for more black holes to form there. And so far astronomers have detected at least 34 additional black holes of a more conventional size of around 5 to 10 times the Sun's mass. Blue and red stars near center of M31. Surrounding the supermassive black hole located at the heart of the Andromeda Galaxy's central bulge is a light-year-wide disk of around 400 hot blue stars orbiting it at 2.2 million miles per hour. The disk is situated 5 light-years away from the black hole, and in turn is encircled by an elliptical ring of older, red stars. The unusual juxtaposition of these blue and red stars suggests that the blue stars are actually older stars that on their way to becoming red giants shed their outer layers to reveal their blue hot cores. The number of blue stars then falls with the distance away from the center, and the galaxy's outer rim delimits the older, more mature red stars. The Andromeda Galaxy has a double nucleus. What sets Andromeda apart from our own galaxy is the fact that it has a double nucleus. Likely because somewhere between 5 and 9 billion years ago 2 smaller galaxies merged together and the nuclei are now in orbit around each other. One of the compact star clusters is designated P1, while P2 is dimmer, but contains a black hole. They will eventually blend into one body in a few billion years. M31 is orbited by 14 plus dwarf galaxies. The Andromeda Galaxy possesses around 450 large globular clusters, the most massive being Mayal 2, G1, which is situated 130,000 light-years from the galaxy's nucleus, consists of more than 300,000 old stars, and is twice as bright as our Milky Way's most luminous globular cluster, Omega Centauri. Interestingly, the majority of Andromeda's satellites have formed a 1 million light-years wide and 30,000 light-years thick ring around its center, and rotate around its core in an immense plane. Though Andromeda's globular clusters are about the same size as its dwarf spheroidal galaxies, the former have virtually no dark matter and so are considered different objects. Andromeda and Milky Way on collision course. Andromeda is going to combine with our galaxy, the Milky Way, in the distant future. At this very moment, our 2 galaxies are approaching each other between 100 and 140 km/s, 60 to 87 miles/sec. In about 4 billion years we're going to merge, probably having a triple nucleus for a while the stars we are familiar with will also form new star constellations. But eventually, the galactic collision will settle down resulting in a brand new massive elliptical galaxy. Of course, when 2 galaxies come together you might think there would be a lot of collisions. It seems logical that a whole bunch of little red dwarf stars, the most common sort of star in any galaxy, would combine to make many more large white suns, like our own. However, the truth is that the space between the stars is so vast that there might be no collisions at all. What will happen is that lots of stars will be flung off into deep space and become wandering solar systems. But the large majority will remain associated and form a large ball of stars. M31 sparked the theory of island universes. It wasn't until astronomer Eber Daust Curtis, 1872 to 1942, was studying the Andromeda Nebula and studied novae, exploding stars, that this opinion began to change about whether M31 was in fact an island universe, beyond our own Milky Way. Curtis observed a nova in Andromeda, and after comparing its data to photographic records of 11 more novae, he noticed that on average they were 10 magnitudes dimmer. than the ones which took place within the Milky Way. Doing some calculations, he then came up with a distance of 150,000 parsecs, 489,234 light-years, for the Andromeda Nebula, a distance placing it outside of our own galaxy. And so proposed his island universes theory that asserted that spiral nebulae were in fact separate galaxies. M31 proved the existence of galaxies. The great debate remained unresolved until 1925 when Edwin Hubble first calculated the distance to the Andromeda Nebula, showing that it was clearly outside of the Milky Way galaxy. Using his 2.5 meters (100) telescope, Hubble produced photos that showed parts of spiral nebulae to be collections of individual stars. While he also used stars called Cepheid variables to calculate the distance to the Andromeda galaxy, using parallax measurements. What do you think of our video? If you like our video, then comment in the comment section. And do like our video. And subscribe our channel. Thanks for watching.